Hello all, welcome back to my YouTube channel. So guys, this is video 5 of our machine learning playlist, and in this particular video we'll be discussing about feature transformation in machine learning, and I'll be giving you all a real-time example which will help you all to easily understand feature transformation, and also I'll be telling you all the main drawbacks or the disadvantages you get in your model if you don't perform feature transformation in this particular video. So guys, now let's not waste our time. Let's dive into the computer screen and discuss more about that. Before that, if you're not subscribed the channel, do subscribe the channel and on the bell notification. Now let's dive into my computer screen. So guys, now let's start the topic. Before this, let me mention you all, this is video 5. So previously there are 4 videos of this particular machine learning playlist which you require to watch it. You can have a look on that, and for every videos we are writing articles like this. You can see here, this is article for this particular video where we'll be having the every detailed information which you can use for your further reading and analysis. You don't need to make any notes of what I am teaching. Just try to understand the topics, it's enough, and you will be getting this particular article link in this video description. Now let's not waste our time, let's continue with the topic. So feature transformation in machine learning. So before I explain you all about this article, let me give you all a small example, real time example, so that you will get an idea. Okay, so for example, take like your mom or else even you might be cooking at your home. So if you are just cooking some food or something, so what you will do, you will be whatever ingredients you require, you will prepare and you keep it aside, right? So whatever ingredients, like for example vegetables or meat, you are directly not going to put it on the vessels for cooking, right? You have to first, if it's a vegetables, you have to chop it, and if it's a meat, you will be washing it and marinating it, right? So the same way, if you get a data in machine learning, you will not be directly giving that machine learning data whatever we get, right? Data sets, you are not going to feed that to the machine learning model, or else you are not going to directly train the model with that particular data set which you get, because there will be many things which you have to do, pre-processing you have to do, and feature transformations you have to do, and mainly your data will be in the textual format, and machine learning cannot understand the data in textual format. Not only machine learning, any languages whichever it is, they cannot directly understand whatever it is there in a textual format or a English language. You only computer can understand in zeros and ones, right? You all know that, right? So now what we have to do, we have to make the transformation of that particular data set whatever we get, we have to encode it, and we have many features to be done. So about those particular features we'll be discussing here. So for that I just gave a basic example of cooking. So how many of you all like cooking? Just comment below, let us see. And or else how many of them have at least cooked once, they have tried to cook? So just comment below, I would like to hear your experience. Now let's continue with this article. So guys, firstly feature transformation. So here is another example which you can have a look to understand better about email spam classifier. If you read this particular example, you will get it. I am not going to explain because the basic example is enough. So you can see here, in feature engineering, you will be having feature construction, feature extraction, and feature transformation. In feature transformation, you will be having feature scaling, encoding the categorical data, numerical data, and column transfer, and many other. These all are the topics which you will be having in feature transformation. We will be discussing one after another. So what is mainly feature transformation? It involves like converting or modifying the existing features with your data to extract more meaningful information. Like for example, you have the data, right? Whichever you have, from that what we will be doing, we can get extract the features if we require, or else even we have to convert that particular data, we have to encode the data. That's nothing but we are trying to explain here. Extracting feature in a sense, like for example, take a time series data set or a stock prediction data set. So you know that you will be having, let's take an example of TCS. So now the TCS stock price. So if you see, for example, let me open the screen. TCS. So this is the TCS stock graph. Okay, you can see it, New York Exchange. This is not TCS. Yeah, let me open this. So you can see it. This is the TCS stock graph, and in this you can see the uptrends and downtrends of that particular data. So I have asked for TCS. Yeah, this is in dollars, not this one. So you can see here, it has like this graph, right? You can see here, everyone. So this graph, particular graph, what it is showing, you can see the time below this. So you can see here the time, right? 10 a.m., 11 a.m. And if I hover on this particular data also, you can see here at 10, 22, 23, and of that particular date. So this is nothing but a time series data set, a kind of time series data set where you will be storing date, month, and year. It is there. So you can see here 5th Jan 2024. So it's nothing but 24 they have written, and 10:32 or 10:31, whatever time it is. So what it happens when it comes to the time series analysis or a stock data, these all data will be recorded at a particular point so that we can use it for further analysis. Here if you see 5th Jan 24, it will be directly recorded in that particular name. So what we can do, like in that particular cells, whatever cell we have, right, in the dataset Excel cell, if you take a CSV as an example, so 5/01/24. So it's nothing but it's of 5th January 24. In this particular data, what we can do, so for example, you want to see only the particular analysis of that particular month, and you don't want of any other months. So you can directly, what you can do, you can extract this particular data again, feature extraction. You can separate month, date, and year from that one particular column. From this one particular column, you can separate year separately, month separately, and date separately. What it happens when you separate it, so when you separate that particular things, right, what it happens, if you want, for example, you have TCS this data of 10 years, and if you want to analyze according to that particular year, you can automatically segregate it easily if you separate it out, and you can get the analysis properly. Or if you want only, if you have 6 months of data, and if you want only the January month data, and you don't want any other data, so you can directly separate it out with the help of this month column, whatever you have extracted the feature. You're getting my point. This is a basic example which I am telling you all. Okay, so using this way, you can like extract, and you can perform using the feature transformation method. Okay, don't worry, we'll be having the practical sessions also very soon. You have to understand this theory first, so that when we are performing practicals, you don't, I mean, whatever code implementations when we are doing, you don't stuck in between, like why I am doing that particular extraction or analysis. Okay, so why feature transformation is important, I have explained you all already, so yeah, I'm just skipping this out. So I'll just read out the main advantages, like enhancing model performance. That's because I told you all, right, if you directly give the normal whatever you have extracted in this, like this, if you give this, the model performance will not be good. So if you have to again segregate with 2024 year only in that particular data, and finding out like which month, again it will take more time. If you are going to do, time complexity will be more, and also the model performance will not be good. When you have this, then even the training time and the execution time will take more, because machine learning will take more time in understanding it. So instead of that, when you extract the features out, when you separate it out, like date, month, and year, if you separate it out, then what it happens, according to the month, it will immediately train, because it knows in that particular month it want only this. It will even train faster, and it will enhance the model performance also. So unearthing the hidden patterns, like with the help of feature extraction, we can recognize the hidden patterns. You can take example of this only. So based on that month, you can see, like for example, based on this particular January month, like this is yesterday's stocks. Okay, so you can see yesterday's stock analysis based on that particular time. If you take, so between 12 to 1 o'clock, where is the uptrend, where is the downtrend, or else if you take from 11 to 1 o'clock, you can see here the uptrend was at 11:06, and again it came down and went again at 11:09, then it started to fall at 11:20. So what it happens when you what it happens when you make it segregations easily, and when you try to simplify the data properly and try to extract the features properly, so understanding the hidden patterns will be easy for us, and even we can perform the analysis and also model training very well. Reducing dimensionality. In some cases, feature transformation can help us reducing the dimensionality of that particular data. This is not only specifies the model performance but also helps us in preventing issues like curse of dimensionality, which can lead to overfitting of that particular data. It's nothing but sometimes there is a chance, because of if we don't perform feature transformation, there is a chance that the dimensions of that particular data might increase when you're encoding, and it might even cause overfitting of your data when you like extract the features and when you perform feature transformation properly. So dimensionality reduction problem will not come to us. Some of the common techniques in feature transformation, we'll be seeing this, and one by one for each and every topic you will be getting a video of this particular topics, don't worry. So first one, feature scaling. One of the fundamental topic is nothing but feature scaling, which deals with ensuring that all features are of similar scale. Like common method includes min-max scaling and standardization. It's nothing but like this feature scaling will help us like maintain the data in one common feature, like min-max scaling and even z-score scaling, or else you can say standardization. What it mainly does is like whatever features or whichever features are at far, also it will try to bring them close, and it will make all the features in a similar one scale, one line of scale, so that it will help us the model training time will also be very less, and also it will help for the model training, better training and also performance. Feature construction. Creating new features by combining or modifying existing features. For instance, in a house price prediction model, you might construct a new feature that representing the number of bathrooms, ratio of the number of bathrooms to the number of bedrooms, which can provide valuable information about the house. This is just an example. So like you can either combine two features, or you can even modify the feature, like you can extract the feature, how I told you all example of the stock price. Encoding categorical data such as product categories or city names, or it can be encoded into numerical patterns. That is because machine learning can only understand in zeros and ones, as I told earlier. For this encoding, what we'll be using label encoding, ordinal encoding, one hot encoding, and there is something called feature hashing, and there are many other encoding techniques which you might explore further, and even we'll be recording videos. If you want, you can have a look on those encoding techniques, have a search on that, you will get a detailed overview about this encoding. Don't worry about all these particular topics. Next videos will be related to these topics only, and it will be important for you all. So let me tell you all the next video, which is nothing but feature scaling. In my next video, I'll be showing you all feature scaling, and I'll be helping you all to understand this better, and if required, we'll be performing the practical implementation also for this. And from here your practical starts, from feature construction, encoding categorical data, which is nothing but like coding parts. We will be having the theory part also a bit, I'll be explaining, then we will be diving into the coding part. Column transformers and pipeline. Column transformers allows you to apply different pre-processing steps to different subsets of the feature, and also pipeline stream enter the data processing and modeling process. So it will help us to do column transformations and also to create a pipeline like training. For example, if you want to start this particular process, we cannot like continuously, if you have one particular data set, it's fine, but when you go to the industries, in the industries what it happens, you will be having many data sets, and each and every second you will be getting one or the other new data sets and new features, and you will be getting new CSV files or JSON files, any files you can take. So at that particular point, you cannot sit and always pre-process the data and always like extract the data and then encode the data and then train the model. It will take more time. So for that, what we use the method called pipeline encoding, or else you can say pipeline creating a pipeline, where what it happens, we'll be like triggering it out, or you can say automating it easily. So once we start, then it means it should perform all the steps from data, getting the data, and data cleaning, handling the missing values, then finally it will be like feature transfer extraction, then feature transformation and encoding, feature encoding, and after that it will go for model like train test split, and then for model training, and finally to the model evaluation. So like this there will be many steps which it will perform automatically when you use pipeline method. We'll be doing on that also, don't worry, like we'll be creating a separate video on this. And after this particular topics, whatever it is there, and the coding part, once this all is done, we'll be creating a complete end-to-end project from basic level to like basic, like getting data from cloud to complete end-to-end, like getting a UI where you will be seeing everything like input, outputs, everything. We'll be having the complete end-to-end project we'll be doing in this particular ML playlist. Function transformers. Function transformers involve applying custom function to features, often used with pipeline workflow to perform specific data transformation. So this is also used in pipeline workflows for performing data transformation. We'll be seeing that when it comes to this particular topic. Power transformation is also same. We'll be using at that particular pipeline methods only, like box Cox and even Yo Johnson transformers. There are many other transformers also. Handling mixed data, like when you have data set contains both numerical and categorical data, then you require to manage both the types appropriately. So for that, what we'll be doing, what are our calls, what we'll be taking to manage that particular data, or else you can say like extract the data. We'll be seeing that. Handling missing values and outliers, this also will be doing in our upcoming videos. These techniques represent the toolkit you will be using to make sense of complex data and prepare it for machine learning. So these all techniques, after this particular video, whatever will be coming from the 6th video, these all whatever you are seeing right until this 10th topic, everything will be one after another video is related to all these 10 topics only. Make sure if you want, you can explore about this, or you can even read these particular articles whichever will be releasing one after another. You can follow us on Medium. You can follow this guy Vinod Kumar on Medium. He's a friend of mine. You can follow him, and you will be getting each and every articles whenever he release. You will be getting the notification, so that before I release the video, you can even read those articles. So guys, that's all for today's video. If you all like my explanation, do connect with me on LinkedIn. So if you see on my YouTube channel, you will be having the LinkedIn icon. Let me show you all. So guys, here you have the LinkedIn icon. You can click on this and you can connect with me, or else even you have here the file links option. If you click on this, you will be having here my LinkedIn account. So just directly redirect to my LinkedIn. Just click on this, you will be redirecting to my LinkedIn and connect with me, so that if you have any doubts, you can directly ask to me, or else you can even ask me any suggestions you require, or if you want to give any suggestions, you can give me on LinkedIn. So guys, that's all for today's video. Do like, share and subscribe the channel. Thank you all. We'll meet you all in the next video. Bye bye.